In this lab, you're going to use an ultrasonic transmitter and receiver plugged into the end of your breadboard. So what you're seeing here on this breadboard is the transmitting circuit and the receiving circuit over here. The receiving circuit has a series of filters and amplifiers to condition the final received signal. Now, the transmitted circuit involves a chip that we haven't used before. This chip has a logic device on it called an AND gate. And what this AND gate does is it takes two digital inputs, and combines them, in this case, to be either a high output or a low output, depending on what these signals are. The digital output is going to be either a high value, which would be 3 volts, or a low value, which is 0 volts. And we're going to set channel A up so that it will give us a signal that is a 40 kilohertz signal. And you can imagine this signal propagating the whole time. And channel B we will set up to give us a signal that just repeats like every, let's say, 10 milliseconds. I have a signal like this, and it just gives me a small window that is about 0.2 milliseconds. So what happens is these two signals will be fed to our AND gate here, and this AND gate will give us an output that is high when both of these A and B are also high, and is low when that condition isn't true. We'll send this V out to drive the transmitter. So what this does for us is we're going to create basically a tiny little beep that comes along every 10 milliseconds. And that little tweet will be our ultrasonic signal that we send out to bounce off of an object, and then we receive it back to figure out the distance between the reflected signal and the receiver. You're going to build an ultrasonic rangefinder, and as you can see, I'm moving this rangefinder closer and further away from the screen, and you can see that the reflected wave changes its distance and time relative to the gating signal, which is that blue signal that represents the transmitted signal. The gating signal is the start of the transmitted signal. The reflected signal is the larger one, and these smaller ones are from other objects in the room. The initial transmitted burst is picked up by the receiver because it's right next to the transmitter. So in order to figure out the distance to the transmitted object, you'll measure the time from the start of the transmission, which is its sound that you're sending to the wall, and the distance for when it returns, and that's twice the distance. You'll use this time and the speed of sound to measure the distance to the reflected object. So the ultrasonic burst will travel from the transmitter to the receiver, and you'll figure out the distance, x, by using the speed of sound. So just as a reminder, our sensor is the ultrasonic, essentially it's a speaker. The speaker hardware is the same for the transmitted as well as the received signal, but they're different devices. In this lab, the instrumentation is going to be used with these digital outputs to drive the ultrasonic transmitter, and you're going to combine a couple of digital signals to produce this little envelope of a 40 kilohertz burst. So that will be the transmitted signal. And of course, the received signal will be picked up by a different ultrasonic speaker. And what you want to do then is take that signal and filter and of course amplify the signal to just isolate the reflected burst, and that will be your voltage out. So you'll use that data to calculate the distance to the reflected object. The challenge in designing the receiver circuit is in collecting the reflected signal. And this reflected signal, of course, is this 40 kilohertz burst. So you'll want to build a circuit that will filter out everything except that 40 kilohertz reflection. And once you are able to isolate that reflection, then you'll want to measure the distance in time between the gated signal and the reflected signal. The most recent practice set is going to be very useful for ideas that will give you both filtering and amplification in your receiver circuit. So these different configurations are what's called active filters, and they are amplifiers at the same time. And since they have the op amp inside of the topology, it will separate electrically the effects of one filter amplifier from the next one. So we encourage you to use these active filters for your receiver design.